Okay, we are on page number 2, and we have an expression that was graphed out as a function because it passes the vertical line test. Please remember it does not pass the horizontal line test because there are horizontal lines that intersect the graph at more than one place. So it does not pass the horizontal line test, which means it is not one-to-one. Another thing you should know is because the left side goes up, the right side goes down, and there's a connection in between, this is definitely an onto function. All right, so that is true. So it's a function that's not one-to-one, but it's definitely onto. Okay, so now let's answer the questions. In order for me to actually figure out what the zeros are, you have to look at the x-axis and see where the function intersects the x-axis. There are 3 zeros. One of them is at -3. There is another one at -1, and a third one at +2. Each one of them, when you look at it, seems to go through the x-axis like a straight line, which means they all have multiplicity 1. So when you're asked to write the equation in factored form, you're going to start off with f of x is equal to, you need a constant of a in the front always, and then you go to the zeros. If my first 0 is -3, the factor is x plus 3. My second 0 is -1, my factor is x plus 1. And my third one is 2, so my factor is x minus 2. And this is how I want you to write down the equation in factored form. When it comes to the y-intercept, basically you got to look at the y-axis and figure out where the graph crosses the y-axis. But anytime it uses the word intercept, you have to write it as a point. So that blue dot is the point 0, 6. Then we are up to end behavior. And when we're doing end behavior, anytime it says as x approaches infinity, that means look at the left end. So the left end, oh, sorry, get rid of that. Sorry about that. I said it incorrectly. Let's get rid of all that. My apologies. Anytime it says x goes to infinity, you're looking to the right. I don't know why I said left, but I did. And when you are looking to the right, you're looking where the end is going, and the end is going down, so you're going to answer it as -infinity. Anytime they're asking x to go to -infinity, -infinity is on the left-hand side for x. So when you look at your graph, look where it's going on the left-hand side, and it's going up, which means +infinity. Okay, now, for the next couple of questions, when you are doing this, let's go back to that color. They want to know when is the function increasing. So when is it increasing? Well, I'm just going to erase everything I have in here, just so it looks clear. It is increasing here, and this is the only section it's increasing. You actually don't include the top peak and the bottom valley, but that's the section it's increasing. And when you're doing increasing, you kind of like project where it starts to increase to the x-axis. And it's basically on this window, right? That strip that you're looking at, this section that the function is increasing on, because it's going up in that section. So I have to say from -2 to +1. You never say inclusive, you always leave it as open intervals. So basically, oh, get rid of that. If it's increasing in this middle section, and I'll use yellow because the yellow is quite light to see. If it's increasing in between here and here, because you can tell the graph is going up in that section, well then you should actually know that your graph is decreasing here. So it's decreasing on the left-hand side of -2, and it's decreasing on the right-hand side of +1. So 2 sections, -infinity to -2, it is decreasing, but it's also to infinity. Now, relative max, relative min points. A max point happens to be when you're on the very top of a mountain. There we are. The max point is 1/8. And the min point is whenever you're at the bottom of a valley, which would be right there. That's -2, -4. And that takes care of the first problem. Okay, one more problem on this page, and here is the graph for it. Let's see how we can do with this. I'm looking for the zeros. The zero is any place where your graph intersects the x-axis. I have 3 of them. I have it -3, I have it -1, and I have it +2. Now I like this problem for the following reason. Using yellow because it's light, it goes through like a straight line here, it twists here, and it bounces like a U here. This is multiplicity 1, this is multiplicity 3, and that is multiplicity 2. All right, and you have to know that. So now when I'm asked to write down the equation, you have f of x is equal to, you always start with the constant. You go to the zeros. The first zero is -3. You fill in x plus 3. And then you note the multiplicity is 1, which means write nothing. Then go to the next zero. It's -1. When you fill in the factor, you're putting in +1. But then you see that it's multiplicity 3, which means you make the exponent 3. Then you go to the last zero. If it's 2, the factor is x minus 2. But when you look at your graph, it bounces off, so therefore it's degree 2. And that's my factored form. And you just leave the a as is. When you are going to the y-intercept, you go to your graph and you find the location where it crosses the y-axis, but the word intercept means write it as a point. So that point is 0, 10. When it is asking for the end behavior, for your end behavior, remember, when x approaches infinity, that means you're looking right. You'll notice your picture is going up. So therefore that answer is infinity. And when x is approaching negative infinity, that means look left, but your picture is still going up at the end. So therefore this is positive infinity. My next question is, where is this function increasing? So I'll make it a little bit darker and I will go to a different color. We'll go to this. So increasing, it is increasing along this because I'm going up. You never actually include the top or the bottom. Those are open circles. But it is also increasing from here over. So everywhere in that thicker hot pink color, that's where it's increasing. And you only go for the x's. So I'm going to guess that this is at 2.5 negative. So I'm going to say it's increasing from -2.5. And it increases all the way up to an x value of 1. But then it's increasing again from 2 to infinity. And that takes care of that. When it comes to the decreasing, I think I'm going to use that color. For the decreasing, I'm looking, my picture is going down to here, but it's also going down from here to here. So it's 2 sections that it's decreasing, because we read left to right, from negative infinity to the x value of 2.5. But also decreasing from 1 to 2. And then we are up to the last 2 pieces. So basically, when it is asking for a max point, that would be up here. The point 1, I'm going to wing it and say it's 30. I know it's not perfect. That's the max point. And a min point would be over here, and I'm just going to say it's -2.5, and I'm going to say -35. And answers to finish up page 2.